So we're going to be looking now at question 12b from the 2014 National 5 Physics paper. It says, before lunch, the water rocket. Just to remind you, we're looking at this question here with the water rocket. The water rocket rests on 3 fins on the ground, as we can see in the picture. The area of each fin is in contact with the ground is 2 times 10 to the minus 4 meters squared. Calculate the total pressure exerted on the ground by the fins. So let's consider the area. First of all, there is an area for each fin of 2 times 10 to the minus 4. And so therefore, if there are 3 fins, then the total area is equal to 3 times the area of one fin, which is 2 times 10 to the minus 4. And that is, of course, 6.0 times 10 to the minus 4 square meters. So that's the first part. Then the question is calculate the total pressure. Well, pressure is equal to force divided by area. Now we know the area. The question is what the force is. Well, the force is the weight that was calculated in the previous question, and that weight was 9.2 newtons. And so therefore we just need to insert the two values into the equation. So the force being the weight of 9.2 newtons and the area being what we just calculated, 6.0 times 10 to the negative 4. And so that gives us a pressure of 1.5 times 10 to the power of 4. And the unit is pascals. You could of course use the unit of newtons per square meter as well, and just write that over here, newtons meters to the minus 2. That would also be an appropriate unit, and of course the value should also be 2 significant figures, as everything else is as well. Now of course there is an alternative method which is given in the marking scheme, and that's essentially doing the same formula. So you do P equals F over A, but this time you assume that the force is applied on one fin, and so all of that force, the 9.2 newtons, is applied on one fin, and that would give a pressure for one fin of 4.6 times 10 to the 4 pascals. But of course that isn't the true pressure, because the force is not applied on just one fin, but it's applied on all 3, and so in fact the actual pressure is a third of this pressure. So the true pressure is equal to that value, 4.6 times 10 to the 4 divided by 3, and of course that gives us the answer we expect of 1.5 times 10 to the 4 pascals. So that's the alternative way of doing it. However, I think the first method that I explained makes much more sense.